Hello, my name is Patrick Alvarez, this is Carlos Banks and Diego Quintero, and for our modeling and design of robots class, we were tasked with the project to review surveillance robots. So why are surveillance robots used out in the real world? Now, surveillance robots are tasked with the objectives that could be dangerous or harmful to human beings. They're used in the military to perform tasks such as bomb disposal, surveillance and reconnaissance. They go through several checkpoints and they inspect several areas, mainly for explosives. They clear the routes ahead of the troops to make sure that there's no hostiles in the area. They perform explosive hazard identifications and hazard materials detection. And this is all with the sensors that are on the robot. General trends for surveillance robots. In this industry, there are three main companies that lead the way for surveillance robots. These companies include iRobot, Electrolux AB, and Lockheed Martin Corp. These companies are the ones that take innovation to a whole new level and develop new surveillance robots constantly. Now, surveillance robots usually feature revolute joints. The main surveillance robots feature these joints. Of course, there are some robots that feature prismatic joints as well. They usually carry 3 degrees of freedom or more, depending on the application that are needed for. And of course, they feature the several sensors with all the tasks that they are tasked to do with.
Some earlier design practices for surveillance robots include they were limited with their tasks of what they could perform. What this means is that they could only perform 1 to 2 applications at a certain time, whereas robots nowadays, they're able to conduct more types of applications. Also, earlier designs, they utilize lesser degrees of freedom. What this means is that they could only go up and down or left and right. And also, the designs were more complex, and had inefficient designs. They usually back then, the technology that they had to put inside the robots was cumbersome and inefficient. Also, the robots, they were heavier and were easily deconstructible, whereas nowadays they're reinforced with stronger materials. And as you can see in the future slides, some of the applications they can perform.
For developments for the future for this type of robots includes the increased use of sensor and thermal imagery in order to detect human bodies. Also, this robot could be used in multiple applications and could be used to do multiple tasks at the same time. This robot will also acquire humanoid characteristics, as you can see in this picture. The robot will pretty much look like a human. That design allows them to have more degrees of freedom and perform their tasks with more efficiency. Also, the materials to be used in the robots for the future includes very high quality material that will allow them to endure and to go through tough terrain, and also they could receive high level impacts and keep performing their task without a problem. As you can see in the next video, it will show a robot from this company.
Very versatile, very real. In a situation we don't have to actually put one of our attack team members too close to the situation.
You just don't know, what you're going to encounter.
I see the delay. By having this, we can actually get eyes inside the building.
Being able to push doors open, get around doors, and look around corners, it's great.
The video was perfect. The 3D model in the bottom right corner makes it a lot easier to see exactly what the robot's doing.
Picking up suspicious devices, looking through windows of cars, underneath cars, inside buildings to locate, barricaded subjects. You can really remove the officer from any danger.
As you can see in the video, this robot features very high-end characteristics and very modern features that will allow it to perform all of those tasks without any problem. Now, Carlos will discuss all of our designing process.
This is the surveillance robot that we came up with. It's a 3 degree of freedom, 3 revolute joint robot. We picked a 3 revolute joint over a prismatic or a PRP or RPP robot, simply because of the availability and the accessibility that the 3 revolute robot offers to this design. Also, we picked a 3 revolute robot so it could comply with the tasks that we wanted it to do. For A1, we came up with a design specification of 14 inches. A2, we picked 10.22 inches, and A3, we picked 5.1 inches. The objectives for this robot, we wanted to infiltrate an air duct system with dimensions of up to 20 inches by 25 inches, or as low as 8 inches by 14 inches. We wanted it to, the duties for it to do was to detect possible threats above and below the air duct. Some of the things that we wanted to detect were possible hostiles or hostages in certain situations. We broke down the tasks into task 1. This would be when the robot looks underneath the AC duct to inspect the area underneath, and in task 2 to inspect the area above for other situations.
Now, as Carlos said, the task 1 will be the robot will be performing an underview of the duct. So the first position, it will start at 0 degrees, and the end effector will have a negative 90 degrees rotation pointing to the floor. Then it will move in a circular path all the way to 180 degrees in order to look all the way underneath the duct. If we go to the next slide, we can see how the white line represents the trajectory of the end effector. And as I said before, we'll perform a circular motion, as well as joint 1 and 2. Joint 2 will be closer to the end effector, and joint 1 will be performing a much smaller radius. If we go to the next slide, this is a rendering in SolidWorks, and as you can see, the robot starts from 0 and goes all the way through here and stops here in order to see all the way underneath the duct. Also, the robot will move on the line of the duct at this position, so it won't crash with either of the sides of the duct. Also, we design our robots in order to not to experience any singularity position, and as well as not to crash when it goes down, not to touch itself or the duct.
So in contrast, the second task had to be to look above the air duct. As you can see, our surveillance robot will start at positive 90 degrees and move to 180 to effectively see over the air duct. As we can see in the task 2 plot, the plot is basically a mirror image of task 1. As we can see with the end effector movement, as well as the joint as movement for joint 2, it moves exactly the same as task 1, as well as joint 1 moves with the same radius. Of course, this can be seen as there's no jumping between points, which also means that is not going through a singular position. As we can see here for the animation of task 2, that is performing the objective that it was asked to do, and also it is not making contact with any structures and performing its task effectively.
The overall summary and conclusion of this project, there were 2 specific tasks that were kinematically tested for path trajectories, and they were analyzed successfully. One time in Excel and another time in SolidWorks, and both of the analysis matched up and correlated. Also, there was a survey overviewing the scope of surveillance robots, and it was explained and presented thoroughly with the past, present, and future applications. The design chosen coincided with that of real-world applications and was successfully designed. We based our design off previous designs from iRobot and from Lockheed Martin, and the design that we came up with satisfied the task that we objected it to complete. If you have any questions, just feel free to leave them in the comments, and thank you for your time.